How to solve for diameter using the area calculation. Using the formula from equation 2.8, in order to solve for d, you would first divide both sides of the equal sign by the constant of 0.7854. Looking at the right-hand side of the equation, because the constant of 0.7854 is both the numerator and denominator, they cancel each other out, which will result in this equation. Next, in order to remove the square and solve for d1 by itself, calculate the square root of both sides of the equal sign. Calculating the square root of a square results in canceling the exponent of 2 or square, leaving just the d1. This results in this equation, which can also be written in this way. An alternative method for solving for diameter using the area equation is to rearrange the formula. To determine the diameter, calculate the square root of the area and divide it by the constant of 0.7854. Now, let's use what you've just learned to solve a sample problem. What minimum bore diameter cylinder is required to lift a load of 36 kilonewtons on the extension stroke at an operating pressure of 20 megapascals? First, convert the kilonewtons to newtons. To do that, multiply the 36 kilonewtons by 1,000, which will result in 36,000 newtons. Next, use equation 2.1 to determine the area needed. Since the question is utilizing metrics, use the metric equation. Since the equation is solving for force and the area is needed, the equation can be rearranged to solve for area. The equation then becomes area in square millimeters is equal to force in newtons divided by pressure in megapascals. Since the force of 32 kilonewtons or 36,000 newtons is provided in the question, divide 36,000 by the pressure of 20 megapascals, which is also provided in the question, and that will equal 1,800 square millimeters. Using the area of 1,800 square millimeters calculated in equation 2.8 and picking up from what we've learned, we would pull that 1,800 square millimeters into the equation, divide 1,800 by the constant, that will total 2,291.83. The square root of that number is 47.87, and rounding gives you the correct answer, B, 48 millimeters.